The twinkling spots of light that can be seen in the night sky are stars. The stars that we see in the night sky have existed for a very long time. However, they must have been created somehow. What were they formed from? How were they formed? And can they die? A star is born. Unlike human beings, animals, or plants, stars are not born from parents. Stars were born from interstellar matter. As the name suggests, it is formed from gas and dust floating in between existing stars in a galaxy. Stars are formed by the gravitational contraction of a cloud of interstellar matter or a nebula. When a nebula contracts enough, a very hot protostar is formed in the middle of it. How is this protostar formed? When a nebula crosses a spiral arm of the galaxy, it begins to condense and the internal gravity force increases. This makes the cloud contract rapidly. As the matter condenses, it breaks into pieces. The center of any very large piece of such a cloud reaches temperatures over 1,000,000 degrees, thus giving rise to a protostar. The energy produced at the center of the protostar stops the contraction and a new star has been formed. The remnants of the initial cloud form a flat disk that revolves around the star. This matter can end up condensing and forming the planets that accompany the newly formed star. The nebula may give rise to an average star or a massive star. Massive stars have a shorter lifespan than average stars. This is because the hydrogen supply of a massive star is used up much quicker than an average star due to the high core temperature. A massive star has a lifespan of anything from a couple billion years to as low as 10 million years only. After the protostar is formed, it undergoes the T-Tauri phase. It usually enters this phase after 100,000 years. At this stage, the core temperatures are too low for hydrogen fusion. Only when the temperature reaches about 10 million K, hydrogen fusion can occur. The energy for the star comes entirely from its gravitational force only. In this phase, the star at this point is of the same size as an average star. However, it is much brighter. This can last up to 100 million years and represents a period of fluctuations in the brightness of a star as it tries to balance its gravitational and internal forces. Once nuclear fission starts and equilibrium is achieved, the star is considered a main sequence star. The life of a star. 90% of a star's life is spent in the main sequence stage. A star that is in the main sequence stage is capable of hydrogen fusion. Stars of mass less than zero point 0.5 solar masses stay in the main sequence for a long period of time. Stars with such low masses, or red dwarfs, burn their hydrogen supplies so slowly that none of them have left the main sequence since the beginning of the universe. Average stars like the Sun stay in the main sequence for billions of years. Massive stars, on the other hand, stay in the main sequence for only a few million years. How do stars die? Eventually, the hydrogen which powers the reactions inside a star begins to run out. The star then enters the final phases of its lifetime. As all stars will expand, cool, and change color to become a red giant. What happens next depends on the type of star it is, that is, whether it is average or a massive star. In red giants, the nuclei are made up of very hot and compressed helium. When the temperature in the center of these stars reaches 200 million degrees, the helium nuclei begin to react. The new nuclear reactions bring about heavier elements of carbon, nitrogen, and oxygen. The energy produced by these reactions momentarily stop the contraction in the star. The wrapping of the star is so swollen that the stars begin to lose its outer layers, releasing a hydrogen gas bubble. These bubbles are known as planetary nebulas because, when seen through a small telescope, they appear in the shape of a disk somewhat similar to a planet. The gas bubbles appear as a ring because only its edges are visible. In the center of a planetary nebula, there is always a blue white star. This is the old nucleus of a very compressed and hot red giant which has become exposed after losing its wrapping. Such stars are called white dwarfs. After many thousands of millions of years, it will stop glowing and become a black dwarf. White dwarfs are made up of ice, carbon, and oxygen. They have approximately the same amount of matter as the Sun but are only as big as the Earth. They have a very high density, thousands of times of that of water. The Sun and all other stars with similar masses, that is, average stars, will end their lives as white dwarfs. They are inert stars that will not evolve further. They start to cool over a period of billions of years until they become dark dwarfs. Not all stars end their lives as quietly as the white dwarfs. Massive stars with much more matter than the Sun continue a more complex evolution and finish their existence in a far more spectacular way. The nucleus of these stars are so compressed and hot that more nuclear reactions can occur. When such a star has used up all of its hydrogen, the nucleus becomes compressed and heats up until the carbon reacts, bringing about heavier elements. When the carbon has run out, a similar process begins. These different phases happen quickly because the new nuclear reactions produce less energy each time. Towards the end, the star begins to acquire a structure of layers, with the nucleus being made up of iron. When it is no longer possible to obtain more energy from the iron, the star's center collapses in on itself and the whole star explodes in one great unimaginable bang. This explosion can produce a glow of more than 100 million suns, and we call such an explosion a supernova. Most of the star's matter disperses into space. The explosion produces a rapidly expanding nebula. The Crab Nebula in the constellation Taurus is the remains of a supernova the Chinese astronomers saw in 1054. A supernova scatters materials from inside the star across space. As this matter condenses and clears, a very dense neutron star is left behind. These spin rapidly and can give off streams of radiation known as pulsars. If the star is especially massive, when it explodes, it forms a black hole. Fun fact, a white dwarf star is about as big as the Earth. A neutron star has a diameter of only about 10 kilometers, while a black hole is even more compressed. The entire life cycle of a star can be summed up in the following stages. A stellar nebula is formed. A stellar nebula can give rise to an average star or a massive star. Both of these turn into a red giant, or a massive star might turn into a red supergiant. The red giant then turns into a planetary nebula, and the red supergiant turns into a supernova. The planetary nebula then turns into a white dwarf, and the supernova either turns into a neutron star or a black hole. Thank you, Om Namah Shivaya.